All right, guys, welcome back. So today we are going to start looking at the math we can use in our acceleration problem. Okay, so we are going to look at something called our kinematic equation. And what these equations are going to do is they are going to relate our 5 kinematic variables. And our kinematic variables are variables that describe motion. So our 5 variables that describe motion are going to be delta x, which represents our displacement measured in meters, the time interval with which we are moving, the initial velocity with which we are moving. So this is the velocity that we are moving before we accelerate. That's going to be units of meters per second. And then our final velocity, that's the velocity we reach after our acceleration. And again, since it's velocity, that's measured in meters per second. And acceleration. Okay, so our equations are going to relate these 5 variables. Okay? And acceleration, of course, is measured in meters per second squared. All right, so we are going to walk through how we derive these 5 kinematic equations so that you guys know where they come from. So let's say we have a velocity versus time graph. Time is measured in seconds, velocity is measured in meters. Okay, so let's say we start with an initial velocity and we accelerate over a certain time interval. We know if we want to find our acceleration, what we'd want to do is find the slope of our graph. And to find the slope of our graph, we do the difference in our y values over the difference in our x values. So if we reach our final velocity, to find our slope, we would take our 2 y values, vf minus the initial, all over the time interval with which we are traveling. Okay, so this is going to be our first kinematic equation. So our acceleration is equal to our change in velocity over time. Another way you'll see this written is delta v over t, where that delta just represents change. Okay. If we want to derive our second kinematic equation, we are going to rearrange that slope equation or that equation we had to find our acceleration. Let's say we wanted to solve for our final velocity. We didn't know what our final velocity was, and we wanted to find that. Our first step in solving that would be to multiply both sides by t. So then we'd have at is equal to our final velocity minus our initial. And then our last step to get our final velocity by itself is to add our initial velocity over to either side. And we're then left with our final velocity is equal to our initial velocity plus acceleration times time. So that second kinematic equation we can derive by using our equation from slope. Okay. So both of these will be useful if, let's say, you know your initial velocity, your time, your acceleration, and you're trying to find that final velocity. Okay. Our third kinematic equation we're also going to get by looking at this velocity time graph. So we know the slope of our velocity time graph tells us our acceleration. But we know that our displacement of our object is also equal to the area. If we find the area of this velocity time graph, we'll be able to find our displacement. So if we wanted to find the area of this graph, we'd want to break it up into shapes that we know how to find the area. And we'll find that we have a rectangle and a triangle. So if we wanted to find the area of that rectangle, we would do our height, which is our initial velocity, times time, our base. So to find the area of that rectangle, we do our height of our initial velocity times our base of time. To find the area of that triangle, we know a triangle, we do 1/2 base times height. Okay. In this case, we can see that our base is time. Okay, so how long we're traveling for. And our height, that would be the difference between our final and our initial velocity. Okay. So if we want to find our total area here, we'd add up the area of that bottom rectangle, initial velocity times time, plus the area of that top triangle. So 1/2 base time times the height, which would be our final velocity minus our initial velocity. Because the height of that triangle is only the difference between those two. Okay. So we have kind of a lot going on here. So we might want to clean this up a bit. Okay. So what we can do is we can distribute this 1/2 t into our VF minus VO. Okay. And when we do that, we'll get our initial velocity times time plus 1/2 t times our final velocity minus 1/2 t times our initial velocity. So then if you combine like terms, we have an initial velocity times time here, initial velocity times time there. So we do 1 minus 1/2, and we're left with 1/2 initial velocity times time plus 1/2 final velocity times time. So what we can do here is we can see that we have a 1/2 t in both of these terms. So we can pull those out to the front to make this a little bit easier to work with. So we pull out our VO, our initial velocity, plus our final velocity, all multiplied by 1/2 or divided by 2, and then all times time. This will be our third kinematic equation. So this one would be useful if we do not know our acceleration and we're trying to solve for any of the 4 variables within this equation. Okay, so if we do not know our acceleration, that's when this guy would be. The equations that we've come up with so far all include final velocity. So what do we do if we don't know our final velocity? Okay. So we'll need to come up with an equation that does not include final velocity. So to do that, we are going to go back to this place right here, where we have our displacement is equal to our initial velocity times time plus 1/2 t, final velocity minus our initial. Okay. And the reason why we want to go back to this point is because looking at this first kinematic equation, we can see that our acceleration is equal to VF minus our initial velocity, all divided by time. I can solve this for VF to get it by time. Okay, so we solved this, and we got our final velocity. Oops, sorry. First step there would be to multiply each side by t, and we'll be left with AT is equal to VF minus VO. Okay. We can see we have a VF minus VO here and a final velocity minus initial velocity there. So since we know acceleration times time is the same thing as final velocity minus initial velocity, we can substitute in acceleration times time into this equation. So we get delta x is equal to initial velocity times time plus 1/2 times time times acceleration times time. Since final velocity minus initial velocity is the same thing as acceleration times time, we can just plug that into that equation. So then when we want to simplify this a little bit, we'll get that our displacement is equal to initial velocity times time plus 1/2 AT squared. since we have time times time there. And this is going to be our fourth kinematic equation. And again, this guy is useful when we do not know our final velocity. Okay? We are going to look at one more. Okay, so all of these equations include time. So the last one we're going to look at is, what do we do if we don't know time? Okay, so we are going to go back to this kinematic equation right here, where we had delta x, or our displacement, is equal to initial velocity plus final velocity divided by 2 times time. And we are going to combine that with another kinematic equation. Okay, we are also going to look at acceleration is equal to final velocity minus initial velocity over time. Because we can solve this equation for time to get final velocity minus initial velocity over acceleration is equal to time. Okay? Since final velocity minus initial velocity divided by acceleration and time are the same thing, we can substitute that in for time into that original equation. When we do that, we'll have delta x is equal to initial velocity plus final velocity over 2 times final velocity minus initial velocity all over acceleration. All right. So if we want to simplify this a little bit, it might be useful to get our values out of the denominator. So we can multiply both sides by 2 and acceleration. So we'll have 2 times our acceleration times our displacement is equal to initial velocity, final velocity squared minus initial velocity squared. We get that final velocity squared minus initial velocity squared by foiling these two parentheses. Okay. So if we want to solve for our final velocity, what we can do is add our initial velocity over to either side. And we are left with our final velocity squared is equal to our initial velocity squared plus 2 times our acceleration times our displacement. And this is going to be our fifth and final kinematic equation. So this one is useful when we do not know time. So depending on what variables you are given will determine which one of these 5 kinematic equations you will want to use to help you solve your problem. Okay? So if that's where those 5 equations come from, please let us know if you have any questions.